eternal or necessary creation. The first problematic understanding of creation is also the most complicated to fully understand. It is important to note that the idea of an eternal creation finds its intellectual roots primarily outside of the Judeo-Christian tradition in Greco-Roman philosophy. As has already been mentioned, such philosophy rejected that God could become creator in any sense. However, many philosophers still maintain that God did indeed create the universe. How can those two ideas be reconciled? The solution was to maintain that God has always been creator, that creation is just as eternal as God is. As long as God has been around, creation has been around. In this sense, creation exists because God is creator as a necessary part of the essence of God. That is, God is not God without being creator, a view radically called into question by the doctrine of creation out of nothing. According to such a view, God was not able to choose to not create the universe, but was under ontological, having to do with being what he is, compulsion to create. If we suspend our affirmation of creation out of nothing, this view seems to be plausible at first, but we must consider its implications. If creation is indeed necessary, it means it is not one of many options, but is what it is and could not have been otherwise. If this is the case, how should one go about understanding nature? The answer was seen to be found in Euclidean geometry, one of the first pure and rigorous forms of mathematics. Euclid's geometry began with 5 statements called postulates that were taken to be self-evident. From those 5 postulates, rigorous logic was applied to prove simple theorems. These were then used to prove more complicated theorems. This process continued on, developing into the entire body of geometrical knowledge of the ancient world and, until the development of non-Euclidean geometries in the 20th century, the modern world. What is important to note about this is that all of Euclidean geometry is to be seen as already latent in those first 5 postulates. All geometrical activity is simply a development and exploration of the implication of those ideas. Any theorem can be traced back to those 5 fundamental statements and can be shown to flow directly from them. One problem that regards any system like this is that there is no guarantee that those basic postulates are at all necessary, nor is there any guarantee that there are no more that are needed. This is exactly what happened with the development of non-Euclidean geometries. It was discovered that 4 of the postulates could create a coherent system without the 5th, though it required some redefinition of terms. The result is that even though these other geometries share 4/5 of the basic ideas of Euclid's, they are radically different. Additionally, the groundbreaking work of mathematician Kurt Gödel demonstrated that any formal system, regardless of how rich and complicated, will necessarily be either incomplete, in which case there are some things that we want to know but cannot deduce from the system, or inconsistent, in which case we could prove something to be both true and false, making the system effectively useless. As it turns out, in the ancient world, the search began to discover and articulate what were known as first principles, which would serve the same purpose for understanding the world as the postulates in Euclid's geometry. This leads to 2 main problems. The first of these, in light of what was just said about the precarious nature of selecting these principles or postulates, is that there is a need to be extremely careful about what basic ideas are chosen, as a slight change can have very far-ranging results. The second main problem is that this practice establishes a method of understanding nature that is fundamentally a priori. This means that conclusions about nature are deduced with logic rather than investigated critically. This means that nature itself is never actually engaged, or to be more precise, it is not necessary to engage experimentally to allow it to shape our questions and to provide the answers. This poses 2 problems. The first is that in light of what experimental science has actually disclosed about the universe, such a method of understanding has proved to be woefully inadequate. Nature has turned out to be far more rich, complex, and unexpected than any kind of prediction could have accounted for. The second problem is that it is unbelievably arrogant. It presupposes that knowledge is simply a construct of human reason and that nature is simply a logical unfolding of core ideas that we assume we can determine. The need to actually investigate creation in a critical way will be unpacked further below in an investigation of a view of creation that is more commensurate with Christian faith and revelation.